What we are looking at here is a visualization of the modern enterprise network under constant siege. Every second, millions of data packets collide with the perimeter, and mixed within that standard traffic is a continuous, automated stream of hostile probes and attacks. Standard legacy firewalls rely entirely on basic port and IP address filtering. They check where a connection is coming from and where it is going, a method that fails to detect modern cyber threats camouflaged as legitimate web traffic. To survive this environment, networks rely on next-generation firewalls, or NGFWs. These systems combine basic access control with deep, intelligent inspection, allowing them to look inside the traffic to identify specific applications and active threats. CHECKPT built its firewall architecture specifically to handle this massive scale of enterprise traffic. It processes immense amounts of data without creating a bottleneck or crashing under the weight of deep packet inspection. Sustaining that level of throughput involves moving away from standard hardware limitations and adopting a specialized physical architecture. CHECKPT solves the bottleneck problem through a modular security architecture. Instead of forcing one device to do all the thinking and all the heavy lifting, it separates distinct functions into specialized components. This dashboard represents Smart Console, the graphical interface administrators use to manage the network. From here, a single administrator can monitor logs and write security policies for the entire enterprise. In this diagram, we see how a security policy functions in practice. A policy is a set of condition-action rules that define how traffic is handled based on 4 criteria: source, destination, service, and action. For example, a rule allows incoming HTTPS traffic but explicitly denies older, insecure protocols like Telnet. This design creates a specific division of labor. The management server handles configuration, while the security gateway at the network edge performs physical enforcement. If the central management server controls the rules, what happens to the entire network if that server suddenly crashes or goes offline? Traffic continues flowing. The security gateway operates independently, enforcing the last successfully installed policy it received from the management node. Physically separating the management brain from the enforcement muscle guarantees stability. An administrator might lose the ability to write a new rule for a day, but the network remains fully operational and secure. Basic allow and deny rules are only the first layer. The true power of the security gateway lies in its active, real-time defenses. This is handled by the Threat Prevention Suite. It is a set of deep inspection features running directly on the gateway, designed to detect and block complex malware and attacks mid-transit. Here you can see the Intrusion Prevention System, or IPS, at work. It detects network-based attacks targeting known vulnerabilities. If an external attacker attempts an exploit, like a SQL injection aimed at an internal database, the IPS intercepts and blocks the data shape instantly. Next to the IPS runs the antivirus function. It analyzes files as they traverse the network, identifying malicious signatures and terminating infected file downloads midstream, long before they can reach an employee's hard drive. The defense works in reverse, too. The anti-bot feature monitors internal devices. If a laptop is already infected and tries to silently communicate with an attacker's command and control server, the gateway detects the outbound behavior and severs the connection, preventing data theft. Alongside these security layers, the gateway quietly handles network address translation, or NAT, mapping internal private IP addresses to public IPs, so users can access the internet without exposing the internal network structure. The security gateway is an active, multi-layered filtration plant, processing specific threats in real time. This visualization shows the consequence of active threat prevention. Successfully blocking attacks generates data. A single hour of operation can produce thousands of individual logs, creating an overwhelming amount of noise for a security team. To make sense of the chaos, CHECKPT uses a dedicated monitoring tool called Smart Event, which focuses entirely on real-time event analysis and reporting. In this diagram, you see event correlation in action. Smart Event looks at hundreds of scattered raw logs, like rapid, repeated brute force login attempts, and groups them together. Instead of investigating 500 separate log entries, the administrator receives one single, meaningful alert. Software visibility covers the digital side, but networks still rely on physical hardware. If the physical firewall device loses power or suffers a mechanical failure, a secure network becomes an unreachable network. Look at this high-availability failover setup. If the primary firewall fails, a redundant backup device immediately detects the drop and takes over the traffic flow. Alternatively, in clustering, multiple devices share the load, providing performance boosts and hardware redundancy. By combining a separated modular architecture with intelligent threat prevention and physical hardware clustering, enterprises create a network that continuously cleans its own traffic with absolute zero downtime.